Vanakkam. Now we are going to solve problem 3.21 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. So now we draw the circuit. Consists of one current source here and a voltage source, but it is a dependent voltage source and its value is 3V0. Okay, and this V0 is the voltage available across this 1 kilo ohm. And here we have node 1, node 2 and node 3. And this is our reference node. Since this dependent voltage source is not connected with the reference node, this becomes the super node. So here we have the super node. Okay, now we try to solve this problem. So at node 1 we are going to apply KCL, means this is our node 1, and here we have 3 paths available. So here this 3 milliamps current is flowing into this node and this is leaving, I2 is leaving, similarly this I1 current is also leaving. So this incoming current is equal to sum of the outgoing or the leaving current. So this is 3 milliamps, that is equal to I1 plus I2. So this I1 can be written as, it is V1 minus this V2 divided by this 4 kilo ohm. So we got this. And here it is I2. I2 can be written as V1 minus this V3 divided by this 2 kilo ohm. Okay. So we can write this as, taking the common denominator as 4, then it is V1 minus V2 plus, here it is 2V1 minus 2V3. So when you cross multiply this 4 and 3, we get this as 12. So that it is 3V1, when you combine these two, 3V1 minus V2 minus 2V3. And from this we know that this V2 and V0 are the same. Okay. So we can substitute this, or replacing this V2 by V0, we get this as 12 is equal to 3V1 minus V0 minus 2V3. So that we can write the first equation as 3V1 minus V0 minus 2V3 is equal to 12. Now we are going to apply KCL at this super node 3, 2. Okay. So what are the incoming currents here? This I2 is incoming, this I1 is also incoming, and this I current is leaving. Okay. So we can write this equation as I1 plus I2, that is the summation of the incoming currents at the super node, that is equal to outgoing or leaving current I. So for this I1 we can write, by applying Ohm's law, it is V1 minus V2 divided by this 4K plus this I2 can be written as V1 minus V3 divided by this 2K, that is equal to I current can be written as V2 minus this 0 potential divided by 1, that is V2. But we know already that this V2 can be replaced by V0. So we substitute that in this equation. So V1 minus V0 divided by 4 plus V1 minus V3 divided by 2, that is equal to V0. So taking common denominator, we get this as V1 minus V0 plus 2V1 minus 2V3, that is equal to V0. Okay, V0. Then when you add this, we get 3V1 minus V0 minus 2V3, that is equal to 4V0. You can cross multiply. Okay. So we got the second equation as 3V1 minus 5V0 minus 2V3 equal to 0. So we can take this first equation as well as the second equation. And if you subtract the second equation from the first equation, okay, changing the sign over here, when you add these two, we get this as 4V0, that is equal to this 12. So V0 is equal to 3 volts. That means V2 is equal to 3 volts. So we got this first answer. Now considering the super node, we can apply KVL so that it is V3 minus V2 is equal to minus 3V0. Okay. That V2 is nothing but V0. So V3 minus V0 is equal to minus 3V0. That means V3 is equal to minus 2V0. So we got the fourth equation. So we got the values V0 as 3 volts and V2 as 3 volts already. This is our first answer. Now we write our fourth equation, that is V3 equal to minus 2V0. In this we can substitute the value of V0 as 3. Then we get the value for this V3, which is minus 6 volt. Substituting this V0 value as well as this V3 value in equation 1. What is the equation 1? That is 3v1 minus v0 minus 2v3, that is equal to 12. This is our first equation. In this we substitute the values of this v0 as well as this v3. Then we get this as 3v1 minus 3 plus 12, that is equal to 12. So this 12 get cancelled, so that we get this as 3v1 is equal to 3. That means v1 is equal to 1 volt. Okay, so this is the second answer. So now we got the first answer and the second answer which is asked in the problem. So we got the required answers. Thank you.